All right, I'm going to ask you guys again. I asked you to try 1, 3, and 5. Just try. I understand you might understand it. You might not understand it. I want to clarify and then expand a little bit further today. So the first thing I'm going to ask you to do, please make sure your technology is away. I've noticed we've been getting a little bit lax with some headphones, cell phones. Please make sure they're away. All right. With that being said, can you take out the blank sheet of paper for me, please? I want to recap last class, and I want to answer questions. What do you understand? What do you not understand? What do you need additional clarification from? And like I said, today we're going to expand it a little bit further. Really, it's the exact same concept, but like I said, it's a little bit of an expansion. So, starting off on our blank sheet of paper, we are going to write on the top, locus definition. So, you learned quite a bit last class, or may have or may not have from the video. But I'm hoping we got the equation. Did we get the equation away from the video? It was this y equals, what was their a value out in front? 1 over 4p. Please know it is 1 over 4p. It is not 1/4 p. Okay, that's not the same thing. 1/4 p means 1/4 times p. This is 1 divided by 4p. That's not the same, just to also clarify that. So it's 1 over 4p, and then it's just like our vertex form, x minus h quantity squared plus k. Please know, another way that you could see this equation, I like this one, because if I took away this 1 over 4p, do you already know the x minus h quantity squared plus k part? Do we know that? Right, that's vertex form. That's our comfort zone, which is why I use this manipulation of the formula. The other manipulation, instead of solving for y equals, they can subtract k over, so it becomes y minus k. Then they multiply by 4p out in front and have it equal to x minus h quantity squared. Does that look like anything we know? If you look at that, does that look like anything we know? Then you would also have to remember that it's opposite this sign, which we don't typically do with y. So I use this one because it's building off what we already know. It's building off vertex form. All right, so please know that, again, you may see this. This is just an alternate version. It's not new. It's just a manipulation of the formula. If you subtracted k and then multiplied by 4p. But they mean the exact same thing. All right. So we have this locus definition. We said this was our a value. Do you remember how at the very beginning of the video it talked about how wide and how narrow the parabola was? Well, wait. If I multiply by just 1/4, that's a vertical what? Vertical compression, right? Which is really what this is doing. It's telling us how wide and how narrow our parabola could be. The thing I want to clarify, can you come up here to the upper right-hand corner? Draw a tiny graph. The reason this compression and potentially the stretch does matter, if I give you 2 roots, doesn't matter what they are. Could we draw more than one parabola with the exact same roots? Yeah, we could draw this parabola. We could draw this parabola. I could even draw this parabola. So again, just because they have the same roots doesn't mean they're the same parabola. I could also do the same exact thing. They could have the same vertex. If I had this vertex, this parabola could have that vertex. This parabola could have that vertex. So there's more information. So again, depending on the stretch or depending on the compression could determine, and what deviates, are different parabolas. All right, so then what we talked about, and what you may or may not have gotten away from the video, I want you to start off below this, just drawing a standard parabola. Just our standard x squared, not even negative x squared, but x squared parabola. From last video, we talked about that, believe it or not, this has always existed, you just didn't know it. That all parabolas have a point that exists here and a line that exists here. Do you remember what those were called? What was the line called? The line was the directives. The directrix I consider like a force field, a boundary. You can never ever cross the directrix. Think about it. It's here, it's pushing everything up above. Then this point right here is called the focus, or the focal point. Think about it being the focus. The parabola is bending around. You saw the real life example that I showed you with the magnetic force field, the shavings, right? You saw that example. That really is how this works. There's the focal point, or the focus. That's what we abbreviate. You'll see common with F. And then right here, we know that this point is what? Our vertex. So some key pieces of information. Where does the vertex lie in relation to the focal point and the directrix? Right in the middle, right? Meaning, this distance and this distance are the same. Do we agree with that? What is that? Now here's the key. What is that distance or that length called? If you have your vertex, you go up this and you go down this. What is that called? Or what's even the variable? Allie? What was it? It is equidistant, that's true, but specifically with this diagram. Melody? It's P. It's P up and it's P down, but what is P? P is what? The focal length. The key, though, and the number one mistake with these local questions, these locus questions, is about the focal length. If it's a length or a distance, can you ever have a negative p-value? No. So it's always positive. And the exact opposite would happen if I said, here's my directrix up here, here's my focal point. So it would go directrix, vertex, focal point. And again, that would be our p-value, vertex up, vertex down, that's that p-value. This equation would be y equals, still same thing, but now it's negative 1 over 4p x minus h 1v squared plus 10. I'm going to tell you for any of these focal questions, this little sketch, do you see how I did directrix, vertex, focal? See how it's not even on a graph? If you can give this little sketch every single time, you're going to increase your accuracy by tenfold. If you make a mistake, the first thing I'm going to ask is, where's your sketch? Okay? Any questions on what I just did? Do you feel okay with the focal point? Do you feel okay with the focal length? Right? How do we feel about the equation? Do we feel okay with where this equation is coming from? All right, so then let's take this information and let's go back to our packet. So this was supposed to be a note recap. I did a whole blank page because from what I heard, we needed a little bit more. All right, so I'm actually going to skip number 1. I'm going to come down to number 3. Now, I'm hoping there's pieces of information you can get right away from this. So starting on number 3, I'm hoping right away, can you identify your vertex? Can you identify your vertex? Now, before I even look at the equation, okay, and start taking piece by piece, look at this right now. Watch what I'm going to do. Is this concave up or concave down? Concave up. So before I look at all the pieces, I'm going to come over and draw myself a sketch. I know there's going to be a parabola. I know there's going to be my focal point. I know there's going to be my directrix. Do we agree with that? If you can start off with a sketch, it's going to help you figure out piece by piece. Also, that it goes focal point, vertex, directrix. Labeling those 3 pieces so you know the order as you're working your way down or across. All right, so now breaking down the equation. Can you tell me your vertex? Someone raise your hand. What's your vertex? Go ahead, sit down. Do we agree with negative 1, 3? Again, that would shift it, right? This would shift left or right. If it's plus 1, it moves it left 1, and then this would move it up 3, right? Opposite same. Beautiful. Now, before I even go for the focus of the directrix, can you add your 4th value down here? Can you tell me your P? Now, you could do some math for it, but can you look at this one and just tell me if this is the 1 over 4p portion of our equation, what would our p value be? Do we agree with 2? All right, right away, right? P is equal to 2. Now, I know my vertex, and I'm even going to label that. That's negative 1, 3. What's true? Always true about the vertex and the focal point. What's always true? If I know my vertex, I automatically know something about the focus of the focal point. The x value has to be the same, right? They're in the same vertical plane. I know right away it's going to have to be negative 1. And if my focal length is 2, all right, I'm at my vertex. If I need to go up to my focal point, I'm going up 1, 2. So it's going to be negative 1 what? Negative 1, 5. And then directrix, I'm going to go, so again, up 1, 2. Then I go down 1, 2. What would this line be? Can I just write negative 1? Was it 1? Negative 1? It's 1. Okay. Could I just write 1 and call it a day? It has to be an equation, right? It's a horizontal line, so it has to be y equals 1. Do you feel good with that? Questions? Does that help clarify anything for you? Say, John.
How'd you get 2 for p?
So this idea right here, remember that part of the equation is 1 over 4p, right? So if it's 1 over 8, you could literally set that up and do the math for it, or 4 times what would give you the denominator of 8? 4 times 2, so your p-value is 2. Does that make sense?
Yeah.
But it's a really good question, because in a second, if it wasn't that obvious, like what if this was 1/6 out in front, which it could be, you would set up 1/4 p, that portion of the equation is equal to 1/8, and cross multiply. 1 times 8 is 8, equals 4p, divide by 4, p is equal to 2. See how you could algebraically solve for it as well. All right, then come down to number 5, right away. Is it concave up or concave down? Is it concave up or concave down? Val just says, oh no. I agree. What happened on 5? Is it a y equals equation? It's a what? X equals equation. Let's pause on that one. Let's go over to 6. 6 is our happy place. I meant to flip-flop those two. All right, let's go over to 6. Is it concave up or concave down? Concave up. Can you make it concave down? Can you make it negative for me? I'm drawing my sketch right away. I know, wait, if my parabola is down, above the vertex is going to be my what? My directrix or my focus? Directrix. And below my vertex is going to be my focal point. Draw that sketch every time. So it's going to be directrix, vertex, focal point. And right away, I know I'm also going to have to identify the p-value. So p is equal to. What's your vertex?
7, negative 1.
7, careful, 7, 1. Your focal length is negative 1/4. So what's your p-value? What's your p-value? Do we agree with 1? Is it negative 1? No, because can you have a negative length? No, so p is equal to 1. And if I know my vertex, we already know that the focal point, well wait, if I go up 1 and down 1, if I go up 1, what am I finding? My directrix or my focus? Directrix, so it's going to be y equals, what value? Y equals 2. And if I go down 1, I'm going to find my focus, 7, 0. Questions? Then let's come back up to number 1. A lot's happening here. Remember, I still need my p-value. Is it going to be concave up or concave down? Up. So I'm still going to have the focal point. I'm still going to have the directrix. Right away, what's your vertex? 0, 0. Now here's the tricky part with this one. In order to find my focus and my directrix, I need that focal length first. Do we agree with that part? I need that. What is my focal length here? If you're not sure, what number is really out there? Right, a 1. So we know that the 1 over 4p portion is equal to 1. Do we agree with that? Could I have a focal length of 0? I always get that. Because if I plugged in 0, well wait, that would just be 0 out, right? Can I have a focal length of 0? That would be going up 0 to the directrix and down, up 0 to the focal point, down 0 to the directrix. So p can never be equal to 0. But what value could I plug in there? If you're not sure, could I cross multiply? Make 1 a fraction, 1 over 1. So I would have 1 is equal to 4p. Divide by 4. So p would be equal to, do we agree with 1/4? Are we okay with that? The reason and what just happened, again, we set 1/4 equal to 1. We made it a fraction, so 1 over 1. It cross multiplied. 1 times 1 is 1. 1 times 4p is 4p. Divide by 4, so I have p is equal to 1/4. What it actually is 1 over 4 times 1/4. Do you see that? What is 4 times 1/4? 1. Do you see how that's 1 over 1? The most common mistake I'll get is that the focal length is 4. If the focal length was 4, then it would be 1/16. Do you see the difference? Okay. So that means if I'm going, all right, my vertex was 0, 0. So what would your focal point be? 0, 1/4, or 0.25. What would your directrix be? Y equals negative 0.25. Ellie?
Would you be allowed to write origin for the vertex?
Absolutely, yes.
Okay.
Questions, comments? Do you feel okay with that one? Do we need to practice a little bit more? Flip the page with me then. I'm going to skip around a little bit. I would like you to try right now 1 and 5. The number one thing, listen here, the number one mistake when you're graphing this 0.24 as your focus, make sure you label it F. The biggest mistake is people accidentally switch their vertex from their focal point, and that would mean a whole different problem. Okay, so make sure when you graph it, always sketch it. So I'm going to have y equals negative 2. Focal point of 2, 4. And right away, I'm going to label that F. So if I have my directrix and my focal point, where does your vertex lie? Where does your vertex lie? Does it lie above your focal point, in between your focal point and your directrix, or below your directrix? In between, and where in between? Halfway, right? Right dead smack in the middle. So I'm going to go, well, wait, what's the distance from negative 2 up to 4? That whole distance is, careful, 6. Half of 6 is going to be 3. So I know I'm going to go down 3 from the focal point. 1, 2, 3. Did that work? Y equals negative 2, 2, 1, 2. Oh, I did it rapidly. So right away, then label that your vertex. So now I need my vertex, which is what? I have my directrix, I have my focus, I need my vertex. So my vertex is 2 what? 2, 1. I also, remember those are 4 things I need. I need my directrix, I need my focus, I need my vertex, and my focal length. What is your focal length? We already found it is 3. Is this parabola concave up or concave down? Concave up. So is it going to be positive 1 over 4p or negative? Right away, I'm also going to give myself a giant positive, because that's going to be the mistake if you make it on your quest. So now I put it together. It's going to be y equals 1 over 4p is going to be 1 over what? 4 times p would be 12. So 1 over 12. X minus 2, quantity squared plus 1. Opposite sign. Take a look at 5. My focus is 0, 2. Again, make sure you're labeling focal point. My vertex is 0, negative 1. So if that's my focal point and this is my vertex, is that concave up or concave down? If my focus is above my vertex, is it concave up or concave down? Do we agree with concave up? All right, so right away, I know I'm going to need, I have my focus, I have my vertex, I know I'm going to need my directrix. You see how I'm writing the setup right away? Directrix and focal length. What's your focal length? Do we agree with focal length of 3? And what would your directrix be? 1, 2, 3, more down. Y is equal to, what was it? Negative 4. So I put it together and I would have y is equal to 1/12 again. X minus 0, or you don't have to have that at all, minus 1. Try 6. Actually, go back and try 2 and 6. Try 2 and 6. Alright, come back to me. On number 2, it has a directrix of y equals 4 and a focus of 3, 0. As soon as you know it's a directrix and your focal point is below your directrix, what do you know right away? It's negative or it's concave down. So right away, as soon as you know that, I want you writing a giant negative and circling it. As soon as you know it's going to be concave down. I know I'm missing my vertex and I'm missing my focal length. What was your, if I have my focal point and I have my directrix, what's my vertex? Halfway in between would give me the point 3 what? 3, 2? My focal length therefore would be a p-value of 2. So I would have y is equal to 1 over 4p or 1 over 8, x minus 3 quantity squared plus 2. Do you feel confident in that? I hope not. What's the mistake? Everything that's on the paper is correct, except what's that one detail? Remember, if this is my vertex, 3, 2, we said it was concave down. What's that extra piece of information? What makes your equation concave down? A negative. That's the part that you have to add in. The focal length is not going to tell you that. You have to know from the diagram it needs to be negative. Same idea on 6. If this is my vertex, that's my focal point. I need my directrix, and I need my focal length. If you have your vertex and you have your focal length, if your vertex is above your focal length, it's going to be concave down again. So wait. From my vertex, do I go down below my focal point to find my directrix, or do I go above my vertex? Above. What is your focal length? 4. So what is your directrix? Y equals, I need more voices. What's your directrix? Y equals 9. And again, I know it'd be going concave down, so I'm going to have y is equal to 116 x plus 1 quantity squared plus 5. Do we agree with that? What do we have to remember to do? That negative. Do you see how easy that negative could be and lost? Melvin. So if you wrote it as negative 116, that's the same thing as negative 116, which is the same thing as 1 over negative 16. The only thing you can't write is negative 1 over negative 16. All of these three mean mathematically the exact same thing. Questions? Did this help clarify from last class? Help clarify? Okay, so like I said, then our goal today was to expand it. So as you already kind of saw a little bit of preview, take our blank sheet back out. Do you have enough room, like kind of how I did in quadrants? Do you have enough room here down the bottom? Okay, if you don't, flip it over to the back. I'm going to put everything on one side so it's nice and clear. I'm even going to separate this out from being concave up, concave down. Because now our expansion from academic to honors is that we also have those sideways parabolas, right? The sideways parabolas are going to work the same way. There's a few variations though, right? What's the big thing? What makes a parabola sideways? It's no longer x squared, it's now y squared. So now it's not y equals 1 over 4p x minus h quantity squared plus k. It's x equals, so really the x and y are just switching, right? It's the inverse. So I would have x is equal to 1 over 4p y minus h quantity squared plus 10. In which direction will this face? Is it open to the right or open to the left? Standard sideways is open to the right or open to the left? Open to the right. The negative version, y equals negative 1 over 4p. Oops, I wrote back y equals. Sorry. X equals 1 over 4p y minus h quantity squared plus 10. Now if I was to draw the sketch, directrix, sideways parabola, focal point. So I still have a focal point, I still have my vertex, and I still have my directrix. But what would be different now? Well, something about the directrix, right? Ruth, what would be different? Yeah, it's now a vertical line, so it's always going to be x equals for your directrix. So vertical lines are always x equals, not y equals. Also the relationship between, well wait, did the focal length change at all? Is it still, well now I'm not going up and down. I'm going to the right p, and I'm going to the left p. And then what's the relationship between my vertex and my focal point? Here, when it was vertical, the focal point and the vertex always have the same x value, right? Here, the vertex and the focal point are always going to have the same y value. Are you okay with that part? Things to notice, patterns. Same idea over here. Focal point, vertex, directrix, x is equal to, again, it matters if the focal point is to the left or to the right of the vertex. If the directrix is to the left or the right, and again, I'm still now going to the left of my p-value, and I'm going to my right of my p-value. Do you see how it's the same concept, just expanded a little bit further? All right, so let's go back to that front page of our packet that you got today. We're going to, again, skip number 2. We're going to come down and look at number 4. So we're going to fill in what we know, and I'm going to add p is equal to. So again, before we do anything, I recommend that you start with a sketch. So as soon as you see x is equal to, draw an arrow to that so it stands out. It's x is equal to So it's not going to be up and down. Does this one open to the left or open to the right?
Left.
Do we agree to the left? How did you know left? It's negative, so I know it's going to go this way. Which means my focal point is to the left of my vertex. My directrix is my right of my vertex. Now here's where it gets a little tricky. Do you remember the movements? This moves it, well wait, this one was up and down, and this was left or right, correct? So this is now, is this up or down, or is this left and right? This is left and right. This is up and down. So what would your vertex be? If it's -5, that's actually meaning it's moving where? To the, what's your movement? This is moving it left 5. Do we agree with that? So I'm going to write this out. Left 5. And then remember we said this is up and down. It's still opposite the sign. So if it's -3, your gut wants to say down 3, it's actually going to go up 3. So what would your vertex be if it's moving left 5, up 3? -5, 3. Do you see how now this is your x value and this is your y value? Do you see how that switched? Because now it's a y squared. So this is your x, this is your y. Same opposite. Okay. Then what's my focal length? Because that's the next thing I can get from the equation. What's my focal length? Do we agree with the focal length 3? All right. This is why your diagram is going to help so much. So my vertex is -5, 3. And I have a focal length of 3. So if I go to find my focal point, if I'm going to have to go to the left 3, so if I go left 1, 2, 3, what value does that bring me to? What does that value bring me to? -8, 3. And notice the y values are the same, right? What would your directrix value be? Not y is equal to, but now x is equal to. So now you're going to the right 3. So if you're going to the right 3, it's now -2. So x is equal to -2. Do you see how it's really important that you're working with that diagram? All right, try number 5 for me. Take a second, think it through. All right, let's start off with the vertex that some of you are working through. Remember, this is the shift, right? Is this shift left, right, up, or down? This -4, it's actually going to move it where? Left, right, up, or down? Do we agree with left what? Left 4, are we okay with that part? All right, so it's going left 4. Is it going up or down at all? No, so if it goes left 4, it's just going to be -4, 0. And what would your focal length be? Your focal length is, do we agree with focal length of 4? Are we okay with that part? All right, then take that -4, 0. If I go to the left 4, that's going to bring, I know that's going to have the same y value, that's going to bring me to -8, 0. And if I go to the right 4, that's going to be x is equal to 0, the y-axis. Let's come up to x is equal to y squared. What would your vertex be? This one's going to be one facing to the right. I heard it. The vertex is 0, 0. What did we already say that p value was? It's that p value? Do you remember? 1/4 again. So if this is 0, 0, that means I'm going to have to go to the right 1/4, meaning it's going to be, what would my focal point be? 1/4 or 0.25, 0. And if I go to the left, it's x is equal to negative 1/4 or negative 0.25. All right. When you're ready, flip the page. I'd like you to try 3 and 7. Try 3 and 7 and then pause so we can fix any errors that might be happening. And then we're going to mix it all back again together. Remember, you need those 4 pieces of information. So you need your vertex, you need your focal point, you need your directrix, and you need your focal length. If you're not sure which direction it's going, draw both sketches. Should my vertex be to the right? Should my vertex be to the left of the focal point? Draw the sketches so you know which direction it should be going. Alright, I do want us to come back together and talk about 3 and 7, because I'm going to notice you're going to do a lot right, which is important that you're writing down all those key steps so I can give you as much partial credit as possible. So on number 3, I've got the directrix and I've got the focal point. Can anyone tell me what the vertex would be then? I'm hoping that was pretty easy to identify. What was your vertex? I heard some mumbles. What was your vertex? Say it loud, say it proud. Something 5. 1, 5? Okay, vertex is 1, 5. What is your focal length, your p-value? P is going to be equal to? Do you agree with 3? All right, so now I have x is equal to, and it's going to be 1/12. Should that be positive or that should be negative? If it's 1, 5, it's opening to the right, so it should be positive. Then here's where some of you might struggle. Remember, this right here means if it's 1, 5, I'm moving to the right 1, and I'm moving up 5, correct? So what number should actually be inside this parenthesis? It's moving up 5. Do we agree? It should be negative 5 there, right? That should be a minus 5. Then here it should be plus 1. That right there. But if you wrote this down and you wrote this down, I can give you partial credit. Remember, x, y, but now it's switched, so the y value has to go with the y value, right? Then this is our x value. All right, then take a look at number 7. I have my vertex and my focus. My vertex and my focus. It's bending around the focal point. So right away, I know it's opening to the right. Do we agree with that? Bending around. So I need my directrix, I need my focal length. What is your focal length? If you have your vertex and your focus, it's pretty easy to identify. What's your focal length? 3. Do we agree with that? Do you notice I haven't given you any with directrix and focus? Or sorry, vertex and directrix. Could I do that as well? Yes. Please know I can give you any of the combinations where anything is missing. Then the directrix would be x is equal to, I'm going 3 further, 1, 2, 3. That's going to be x is equal to what? Negative 6. So I have y is equal to, again, 1/12. It's going to be x. Again, it's...
Wait, it's x.
Oh, good catch. X is equal to y. This is my vertex. The y value, right? We need our up and down movement. So this is going to be minus 2 quantity squared and then minus 3. Do we agree with that? This tells me I'm moving left 3, up 2. Do you see why I really focused on those shifts with that parabola? Okay. Try 4 and 8. Don't ask me why that part on 8 is bold. Nothing else is bold. I don't know why that became bold. It's not like it's different or more important. I don't know why it defaulted to bold. Try 4 and 8 for me. Take your time. And that was a good question. So your graph does have to match your equation. Okay, so when you have these problems, I will be actually grading your sketches, your graphs, and your equations. It's pretty much a point for any of the missing pieces. Directrix and focal length, 2 points for the equation. And then 2 points for the graph typically. together and take a look at number 4. So I graphed. Again, it's x is equal to, so no, that was the vertical line, negative 2, 4. If I have my focal point, this is my focal point, my directrix. So again, I'm looking for the vertex. What's your vertex value? Vertex would be halfway between, so it would be what? Do we agree with 1, 3? 1, 3. What's your focal length then? 3. So I have x is equal to 1/12. X, oops, y. Opposite sign. Quantity squared. Loss 1. Do we feel good with that? What's the mistake? What's the mistake? What's negative? Right? It has to be focusing to the left. So it should be negative. Now do we agree? Beautiful. Again, really emphasizing that negative portion. I keep doing it because if you miss something on a quest, that's what it's going to be. All right, same idea. I have my vertex. I have my focus. Is this one going to open to the left or is it going to open to the right? It matters, right? If you mislabel those or misgraph them, it's focusing or bending around the right. So I'm missing my focal length and I'm missing my directrix. If I have the vertex and I have my focal length, I have the focal point. What's your focal length? Negative 1, 1, negative 6, 1. Your focal length would be, do we agree with 5? All right, so then your directrix, I move 5, continuing in the opposite direction. So it's going to be x is equal to negative 11. So I'm going to have x equals 1/20. X. I'm going to do it every single time. Y minus 1 quantity squared minus 6. Do we agree with that? Feel pretty good. Left, right, up, down. All right. Last quote-unquote new thing I need to show you. Flip to the next page. So the difference is, if you look at our blank piece of paper, it's nice if they always gave us this in, well, really vertex form, but now we know more about our A value, so we can tell more about the compression or if it was a stretch. So you can tell us more about the directrix and the focal length. But are they always going to give it to you in this form? Of course not. Okay, we might actually have to solve so it's in this form. To put it in this form, wait, what did we do to go from, real quick, standard form, y equals ax squared on the other side, please, ax squared plus bx plus c, to y equals a x minus h quantity squared plus k. This, when I'm reviewing the students or working with students, it seems to be something we may have forgotten. I'm doing it on the back of the blank paper, so this is where we get all those notes. I'm just doing it on the back. Remind me real quick, how do I go from standard form into vertex form? Complete the square. And then remind me, how do we go from vertex form back to standard form? We expand it out. So the exact idea, if I had it in standard form, and I want to put it into our locus definition, is that really anything different than our vertex form? Is that anything different than our vertex form? No, it's just now I know more about what's happening to that A value in order to be able to find the focal length and the directrix. So it's still the same thing. I would complete the square and expand back if I needed to. All right. So when we use this, look at the next page in our packet. It's saying, all right, for each of the following, find those 4 things. Find our vertex, our focal point, our directrix, and our focal length. So again, V, F, D, and P. All right, looking at it right now, is it in vertex form? No. Do you remember what we need to do to complete the square to put it in the vertex form? What was step 1 of completing the square? Do you remember? Close. That's if we were solving. If we were solving, we set it equal to 0. Step 1 was to make sure our A value was 1. Is our A value 1? Okay. Then step 2 was to bring over the C value. So is it okay that it's 4y? Yeah, we're not going to do anything with that until the end, actually. So 4y, I'm going to subtract the 12. I know I'm going to be adding something to both sides. Take that negative 8. Divide by 2 and squared. What's negative 8 divided by 2 quantity squared? Add 16 to both sides. So now I have x minus 4 quantity squared equals 4y plus 4. I subtract 4 to the other side. And now here's the part where it gets tricky. In order to put it in vertex form, I'm not done. What do I need to do at this point? I need y equals, right? I have to divide through by what? But here's the catch. What number is really in front of these parentheses? A 1, correct? When I divide by 4, am I dividing by what's underneath or what's inside the parentheses? No. You cannot divide because this entire group is being squared. Exponents come before that. So what I'm really dividing is the 1 in front. So 1/4. And then I also have to remember to also divide that negative 4 by 4. So I would have y is equal to 1/4 x minus 4. Again, notice that did not change. Minus 1. Now looking at it, can we identify the vertex? What's your vertex? 4, negative 1. What's your focal length? 1. So I'm going to graph that. 4, negative 1. Label it, that's my vertex. But now I need to know, is this concave up? Is it concave down? Am I going to the left? Am I going to the right? Which direction am I going? Concave up, correct? It's positive, so I'm going to draw myself that little sketch so I don't forget. So I'm going to go up 1 and I'm going to go down 1. When I go up 1, what am I finding? The focal point. So I know my focal point is 4, 0. And when I go down 1, I'm going to find the directrix. So y would be equal to negative 2. Please make sure you're actually sketching that parabola. If you don't draw the parabola, even if all that other information is there, I can't give you full credit. We have our vertex, we have our focal length, we have our focal point, and we have a directrix. Yeah?
Does it matter if the parabola is like y or like?
Right now, that's a really good question. Does it matter what your parabola looks like? Right now, no. Can we increase our accuracy with this one? Looking at that, well, not really standard form. I could divide everything by 4 from the beginning and find out my y-intercept would actually be 3. Because if I divided by 4, divided by 4, divided by 4, do you see how you could get that y-intercept of 3? So, but right now, I'm not even going to ask for that extra accuracy. Just give me a parabola and you're good. Okay. All right, then take a look at number 2. How did number 2 change? Look at the equation before you start working on it. What's different? Now y is squared. Do you see that? So look what we did before. When x was squared, you see how I have that 4y term by itself? So now y squared. So I'm going to want y squared minus 6y. And I'm going to have to bring that 16x and the 25 to the other side. So plus blank is going to be equal to negative 16x minus 25 plus blank. Are you okay with why I brought that 16x and the 25 over? Because I know it's y squared, I know my general equation is going to be that x equals 1 over 4p y minus k quantity squared plus h. Right? So in order to have x equals, I'm going to have to bring the x over to the other side. And in order to complete the square, I have to bring the constant to the other side. What number am I adding to both sides? What number am I adding? Take the negative 6 divided by 2 squared would add what? 9. So I would have y minus 3 quantity squared equals negative 16x. What's negative 25 plus 9? Negative what? 16. I add the 16 back over. So I would have y minus 3 quantity squared plus 16 equals negative 16x. And what do I do to finish that? Divide through by negative 16. And remember, you're really dividing 1 by negative 16. So I have x is equal to negative 1/16 y minus 3 quantity squared plus 16. So again, I need my vertex, I need my focal length, I need my focal point, and I need my directrix. So the
minus
what did I do? Oh, thanks. So you start off with the easiest one to find is your focal length. What is your focal length? P would be equal to, do you agree with P is equal to 4? Is it going to open to the left or open to the right?
left.
Open to the left. Now, what would your vertex be? What would your vertex be? Do we agree with negative 1, 3? Remember, it switched. This is now our left and right. This is our up and down. So vertex is negative 1, 3. And now I'm not going to be going up 4 and down 4. I'm going to go to the left 4 and go to the right 4. If it's opening to the left and right, if I go to the left 4, am I finding the focal point or am I finding the directrix? Focal point. So that's something 3. It's now negative 5, 3. And your directrix would be x is equal to. And vertex. Taking a look at number 3 before we do anything else. Is this going to face up? Is it going to face down? Is it going to face left? Is it going to face right? Is it x squared or is it y squared? X squared. So we're talking up and down, right? Is it going to face up or is it going to face down? Up or down? Up or down? Is x squared positive or x squared negative? Right now it looks positive, right? But we got to make sure we actually solve for y. So I know, again, in order to complete the square, I'm going to want to regroup. So I'm going to bring this 12y to the other side, bring my constant to the other side. Go ahead and complete your square. And identify your vertex, your focal length, your focal point, and your directrix.
class. And the internet doesn't use it. It's a great program, except for that seems to happen in English. So as long as it does, as long as it does.
Alright, quick check-in. So, what number did you add to both sides? Did we add 1 to both sides? Alright, we added 1. Do we agree this factored into x plus 1 quantity squared? Equals 12y minus 24. Feeling pretty good? Add 24 to the other side. X plus 1 quantity squared plus 24 equals 12y. Divide everything by 12. Again, it's 1/12. So I would have y equals 1/12 x plus 1 quantity squared plus 2. Feel good with that part? Is that facing up, down, left, or right?
Up.
We agree with up? Alright, so looking at it again, I need my vertex, I need my focal length, I need my focal point, and I need my directrix. So right away, what is your vertex?
-1, 2.
-1, 2. What's your focal length? 3. What's your focal point? So I'm going to go -1, 2. That's my vertex. So if it's up and down, I know I'm going to go up 3, 1, 2, 3. Go down 1, 2, 3. So if I'm at my vertex, if I go up 3, did I find my focal point or my directrix? Focal point and then my directrix, so that's really my line. So directrix is y equals -1, and my focal point is -1, 5. Questions? All right. What I'm going to have you do, we covered a lot, right? We reviewed what we did from last class. We talked about sideways, and we talked about putting it into, really taking completing a square and putting it into this locus definition form. All right. So, what I'd like you to do, stay with me. We're going to mark up some problems. I'm going to give you some time in class to start your homework. I'm giving you 12 problems, which is why I'm giving you some time in class. Okay? So if you could flip, because we're going to mark them up. Flip the page with me. We're going to do pretty much 4 of each. Okay? So I'm going to have you do number 4. We'll do 3 of each. Well, 3 of 6. 4, 5, and 6. You're going to have to do 7. 4, 5, 6. Flip the page. 1, 2. Skip 3, 4, 5. We're going to do 8, 9. And then we're going to do 12, 13. Please know what I'm thinking is we're going to add an extra class in there because I want to make sure you are the most successful as possible with this quest. So if you could just take a second on that blank piece of paper just so it's really very, very clear. I wrote it on my board. Quest B. I see you guys again on Friday. What we'll do is we'll do a review class. Because I think it's important that we're going to review and then we'll actually quest when I see you again on Tuesday. Please know that quest will not be an entire block quest. Okay, we've got to move on. There's more I have to cover to fit everything in before the holiday break. But you also shouldn't need the whole block. Yes.
Wait, what's a quest? Like a quiz?
So it is bigger than a quiz, but smaller than a test. If you remember, I took this unit and I broke it into before Thanksgiving break and after Thanksgiving break. Because can you imagine trying to take a test next week on what we covered 2 weeks before Thanksgiving break? I think it would be a little bit much. So it's a quest. You cannot use a retake on it because it does go into the test category. So the way it is, it's literally one test grade. It's just broken into a smaller number of points and a smaller number of points. Together, it's one test grade. Okay? So if anything, it benefits you because you're focusing on less content rather than trying to focus on everything at once. So it's going to cover 3x3 systems. That was the first thing you guys actually saw before break and after break because we had that one odd day. Circles. We covered super, super quick, really completing the square, identifying the center of the radius. Then we covered systems algebraically, which is really why I covered circles. And then locus definition. We're going to hit a little bit on everything next class. I'm gonna say the largest part where you're probably still struggling, potentially locus definition. Hopefully today helped clarify. But I'm gonna bet most of you are gonna spend most of your review time next class focusing on algebraic systems. Okay, that's where I'm seeing a lot of algebra 1 mistakes come up. Are we good? Alright, you have about 6 more minutes. I bet you could finish 1, if not 2 of those homework questions. Make the most of this time, or you won't get it again.